All right, here we go. I think we're up again. So welcome back to another day of Advent of Code. We're now on day 5 and I'm pretty excited. I'm feeling a little tired today, so I'm not sure how up to my game I will be. But let's just hope it will go well. Yeah, nothing much more to say. I think I'm just happy to be doing these challenges. So let's just hope this will go well today. And we will get the problem up in 10 seconds. So here we go. Day 5, hydrothermal venture. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The summary helpfully produces a list of nearby lines of vents, your puzzle input for you to review. For example, this, which means we're going to be doing more parsing today. Great. Yep, looks fine. That actually looks relatively easy to parse, and I wonder if it's x1, y1 to x2, y2. I wonder if we could like try something a little different today and parse it with sscanf, just because it looks nice. no real good reason for that, but we'll see. For each line of the data, we want to let's see. We got what do we call these? These are called entries. Okay, entries is an array of p. And we have a data number of them. So for each one, we want to say fint.sscanf. Let's see how this works. sscanf requires the string, the format string, and then my things that I'm reading out. So the string would be L. My format string then would be D, comma D, arrow D, comma D. And I want to read that into entries. This is going to be a little bit annoying. Entries I dot x1 dot y1, x2, and y2. And then we'll just print entries and see what we get. I always have a problem with sscanf. It never really seems to do what I want it to do. Whoops. These are meant to be pointers, of course. That looks a lot more promising. The last entry is 26342, and it indeed is 26342. So we know we parsed that properly into our struct. So sscanf, I can't pronounce it. It's a pretty cool thing. Yeah, let's carry on. Each line of the vents is given as a line segment in the format x1, y1. Yeah, we parsed it already. Where x1, y1 are the coordinates of one end of the line. And so I just noticed I had a chat message. So hi there, thanks for joining. Where was I? The coordinates of one end of the line segment here, and x2, y2 are the coordinates of the other end. These line segments include the points at both ends. In other words, include the points, so inclusive. So an entry like 1, 1 to 1, 3 covers the points 1, 1, 1, 2, and 1, 3. 9, 7 to 7, 7 covers points 9, 7, 8, 7, and 7, 7. For now, only consider horizontal and vertical lines. Lines where either x1 equals x2 or y1 equals y2. So for the horizontal and vertical lines from the above list would produce this diagram. In this diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point or dot. Yeah, okay, yep, so it's just the diagram. The top left pair of ones, for example, comes from, the number of lines which cover the point. Right, okay, 2, 2, 2, 1. The bottom row is formed by overlapping 0, 9 to 5, 9 and 0, 9 to 2, 9. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. So first we need to find all the lines that are actually horizontal or vertical. So we're going to call them VH lines. I have no better name. It's just an empty array. It's a little bit strange to write it that way. So here what we'll do is we'll say if entries I.x1 equals entries I.x2 or entries I.y1 equals entries I.y2, like it says in the problem description. Then we also append it to the other one, the other array. So this will be our array of just horizontal and vertical lines. So we'll do a len of entries. We'll also do a len of VH lines, just to see what they're like. It's reasonable. That looks reasonable. And let's just check the actual lines. Yeah, they exist. The lines all look like they're positive numbers. So I might just use a giant array. It's not the most memory efficient, but I think our computers can handle that today. So we just need to keep track of our max x and max y as well. If x1 is greater than max x is entries dot x1. Then we do this with x2. Then we do this with y. That's annoying. Okay, we'll just do it by hand. So let's just check our max x, max y. Okay, we can probably create an array that size. Just make it 1,000 by 1,000. Yeah, why not? Grid is an array of ints. And how many points do at least 2 lines overlap? Yeah, we'll just write it out. For yeah, we'll just make our giant grid. Nothing wrong with that. Oops, that's a mistake. That should be okay. I feel a little iffy about that block of code, but it should be okay. And so now what we do is we just say for every line in our vertical or horizontal lines, we have 2 different cases. If x1 equals x2, then we do something. Otherwise, otherwise, we know that this has to be the other case just based on what we had written. Then we do something else, right? Then we, so if x1 equals y1, then we just say that the points are inclusive, right? So for y equals L dot y1, y less than or equal to L dot y2 because they're inclusive, y plus plus. We don't know that it's y plus plus either, do we? The lines could be backwards. So y1 equals L dot y1, y2 equals L dot y2. If y2 is less than y1, then we swap them. If y2 is less than y1, then y1 equals L dot y2, and the other way around. Yeah. So for each one, we just say grid. I always do my grids y and then x. It's just a habit of mine. Plus plus. Otherwise, we do the same thing with the x's, right? And this is just making sure x1 is always smaller than y1. That should give us the grid, as far as I can tell. Cool. At how many points do at least 2 lines overlap? So I'm actually building the grid, but I feel like, you know what? Yeah, no, let's just do it again. So let's just loop over the grid. For row in the grid, for value in the row, if the value is greater than or equal to 2, which means at least 2 lines, look at that spot, count plus plus, and we print out the count. So yeah, we just drew the lines on the grid exactly like they did in this example here. Filled it in with ones with the number of lines that just added 1 every time a line went over that cell, and then we just counted how many times how many cells are 2 or greater, right? Yeah, 2 or greater. So 5,280 is my answer here apparently. Cool, great. Let's keep going. I think it was quite slow. Unfortunately, considering only horizontal and vertical lines don't give you a full picture, you also need to consider diagonal lines. Because of the limits of the hydrothermal vent mapping system, right? These are whole number cells. The lines in your list will only ever be horizontal, vertical, or a diagonal line at exactly 45 degrees. In other words, an entry like 1, 1, 2, 3, 3 covers the points 1, 1, 2, 2, 3, 3, and so on. You still need to determine the number of points where at least 2 lines overlap. In this example, this is still anywhere in the diagram with a 2 or larger. Now a total of this. Consider all the lines. Okay, so now we're considering all the lines. We actually don't need to use this VH lines anymore. So here what I'm going to do is I'm going to loop over all my lines instead. So if we can keep this case, right? Because if x's are the same, we still do the same thing. We keep this case. If y's are the same, we do the same thing. And then we have the else, where we assume lines are given as 45-degree lines. Then we can do basically the same thing, but we just need to be a little bit careful about how we draw our diagonal lines. So we can't use this min this min-max thing anymore, because there are 4 different ways we can draw the lines. We can go bottom left to top right, top left to bottom right. Yeah, or the other way around. So we just need to make sure that we don't accidentally add or, yeah. Oops, sorry, wrong one. So the easiest way, the most straightforward way for me that I can think of is to just do a little bit of maths and figure out whether I need a +1 or -1. So the way I would do that is I'd say dx is going to be x2 minus x1, right, divided by the absolute value of, no, I can just use math.sine, can't I? Isn't there a math.sine function? What does sine bit do? Reports with it. Oh no, that's not what I want. Okay, there's no sine function, so we'll just have to use math.abs. So L dot x2 minus L dot x1 divided by abs of L dot x2 minus L dot x1. Then we need to, we probably need to say that this is a float on this side. Then we need to say the whole thing is an int again. We do the same thing for the y. So that's just telling us the step, right? The number divided by itself, this is either going to be +1 or -1. So that's just the step for moving towards, from x1 moving towards x2, whether it's positive or negative. So we can say for y is y1, y is less than or equal to y2, and the step size is going to be that either that +1 or -1, which we calculated earlier. We do the same for the x, and we can do the same thing and just add to that spot. And we can only do this because we know that the line is 45 degrees. I'm somewhat happy with this. Just need a few more conversions in here because Go is quite particular about data types. Okay, now that is a huge number, and I'm not sure that I like it. Because that's saying like almost every square is drawn. This less than or equal to is wrong, isn't it? If it doesn't equal, I need it to be if it doesn't equal. If it doesn't equal that plus dy plus dx. Okay, I made a mistake somewhere. I'm almost certain I made a mistake somewhere. There's no way this number is this size. Ah, of course. I made a mistake. I don't want to loop it like this. That's just drawing over every square in the grid. I need to do one loop. Yeah, I need to do one loop. Can I do this in here? Or does Go not like that? Go doesn't like that. So we can do it a little bit different. Y is going to be L1. X is going to be X1. While, and Go, for loops, while loops are just for loops without the other stuff. While, yeah, Y doesn't equal y2 plus dy. We want to increase that, and then y plus equals dy, x plus equals dx. That would help us, that would let us draw the diagonals. I'm somewhat happy with this, so I'm just going to try it first. 16716. If it's not right, we'll dive into a little bit more. No, we got it right. 892. So 900. Pretty bad. Pretty good, I think, for today. I'm pretty happy with that. Thanks, Siam in chat. Thanks for cheering me on. Yeah, I think this is another one of those relatively straightforward challenges where, again, I took some liberties, right? If you're writing proper production code, you probably want to find some ways to optimize this, right? 1,000 and 1,000 by 1,000 grid is 1 megabyte of memory, because 1,000, it's actually more, it's 4 megabytes because these are ints, which are 32, which are 4 bytes wide, right? Because 1,000 by 1,000 is a million values. So you almost definitely don't want to do something like that if this was a real code, but this is a programming puzzle and it's a timed challenge. So 1 megabyte, 4 megabytes, 8 megabytes of memory. I'm happy to throw that at the puzzle. Yeah, that little diagonal thing at the end was a little challenging. The reason this is not equals instead of less than is because I don't know whether y2 is greater than or less than y1. So I can't use if y is less than, or while y is less than L dot y2, because if y1 was already bigger than y2, then we just miss things straight away. And the reason it's not equals L plus y, L dot y2 plus dy is because otherwise we'd miss that final slot, because the points are inclusive of the end. And it has to be plus dy because, again, I don't know if it's bigger or smaller. I don't know if it's +1 or -1. Again, there's the assumption here that the input is correct, right? The problem tells us that the inputs are always 45-degree lines. I didn't check that that is the case, but I just assumed that it was the case. And yeah, it came out correct. So they didn't give us bad input, which is nice. And I think the only other thing in here is just this sscanf that I had at the beginning, which was just a nice way to parse input like this, which is quite regular. And yeah, it's the other way that you could do this is you could do like 2 splits, right? You could do strings.split on the arrow, and then on each side again you split it on the comma, and then you do your number conversion. In this case, actually, sscanf was clearly a lot shorter than yeah, using splits. One more thing that I realized as I was writing this was that I didn't actually have to create this VH lines array, this filtered array of just the horizontal and vertical lines, because in my loop down here, I could have just had this if and then this else if, and then if I commented out this bit, right, for example, that's that last else block, then this is just a solution to part 1, right? And yeah, whereas you just chuck this final else block in for the final lines to get the solution to part 2. So yeah, thanks for watching, and thanks for the congratulations. Appreciate it. And I'll see you again tomorrow for another challenge.